Hello everyone, I'm Karshita. Today's subject is microcontroller and the topic is register allocation. So what is register allocation? A register allocation is a process of assigning a local automatic variables and expression results to a limited number of process register. This can be efficient use of a limited resources. That is, a register allocation is the process of assigning a program variable to a limited set of CPU registers available on the microcontroller. This ensures a efficient use of these precious resources. And also, this register allocation optimizing a program performance. That is, effective register allocation can significantly improve the program performance by reducing the need of costly memory access, enabling the faster execution of code. And this register allocation is a key role in compiler design because it is a fundamental component of the compiler design as it directly impacts the quality of the generated machine code to overall the efficiency of the compiled program. So what is register allocation on microcontroller? Efficient register allocation is a crucial for optimizing the performance on the resource constrained microcontrollers. Careful management of registers can boost the execution speed and minimize the memory usage, enhancing the overall system responsiveness. The importance of efficient register allocation. Efficient register allocation is crucial for microcontroller performance. By optimizing the usage of the limited number of registers, programs can be executed faster and require less memory and also consume less power. This is considered as a critical consideration for resource constrained embedded system. This register allocation also improve the performance by minimizing the memory access, reducing the execution times and improve the overall system responsiveness. And also it reduces the memory footprints. That is, a careful register management allows more program code and data to fit within the microcontroller's limited on-chip memory. And also it has a power efficiency, that is, reducing unnecessary memory operation lowers the microcontroller's energy consumptions, extending the battery life in the portable devices. Moving on to the register types on microcontrollers, there are mainly four types, that is general purpose register, special purpose register, accumulator register and index register. What is general purpose register? These versatile registers can be used to store data, perform arithmetic and logical operations, and serve as pointers to the memory allocation. And coming to the special purpose register, microcontrollers often have dedicated register for special functions such as the program counter, stack pointer, and also stack status flags. Coming to the accumulator registers, the accumulator is a central register that stores the result of arithmetic and logical operations, enabling the efficient data processing. Coming to the index registers are used as pointers to access memory locations, allowing for efficient data manipulation and array indexing. Coming to the factors affecting the register allocation, we can see that microcontroller architecture, program complexity, performance requirement, and memory constraints. Microcontroller architecture is the The underlying architecture of the microcontroller, such as the number of available register and their capabilities, can significantly impact the register allocation process. Coming to the program complexity, the complexity of the code being executed includes the number of variables and the frequency of their use can influence the optimal register allocation strategy. Coming to the performance requirements, the performance need of the application, such as the need for low latency or the high throughput, can guide the register allocation approach to prioritize speed over memory usage. Coming to the memory constraints, the limited memory available on microcontrollers can force trade-offs between register usage and the use of main memory, impacting the register allocation strategy. Coming to the register allocation algorithm, we have mainly three algorithms, that is graph coloring algorithms, linear scan algorithms, and priority based algorithms. Coming to the graph coloring algorithms, these algorithms models the interference between variables as the graph and then use graph coloring techniques to assign the register to a variable. Coming to the linear scan algorithm, it is nothing but the iterative algorithms scans the program linearly and assign the registers based on the lifetimes of variables, aiming to the minimize spill of memory. Coming to the priority based algorithm, these algorithms assign priorities to variables based on the factors like frequency of use and assigns register accordingly, giving the high priority variable preference. ನೀನು ಓಡಾಡ್ತಾ ಇದ್ರೆ next we'll see about the compiler-based register allocation. There are mainly four compiler-based register allocation. The first one is automated optimization, advanced algorithms, and flexible trade-offs, and transparent to developers. Coming to the automated optimization, the compilers can automatically analyze code and efficiently allocate the registers, optimizing the performance without manual intervention. And this compiler-based register allocation are sophisticated register allocation algorithms like graph coloring and the linear scan can produce highly optimized register usage. And these compilers can balance trade-offs like code size, execution speed, and register pressure to meet application requirements. This compiler-based register allocation happens transparently, allowing the developers to focus on high-level design without low-level optimizations. And now we will know about the manual register allocation. The first one is hands-on approach, optimizing performance, flexibility and control, and increased complexity. This manual register allocation allows us to hands-on approach, optimizing performance, flexibility and control, and it is increased complexity. Coming to the hands-on approach with manual register allocation, we can developers directly assign variables to the specific register on the microcontroller. This requires a deep understanding of the processor architecture and instruction set. Coming to the optimizing performance, by carefully selecting the registers, developers can minimize the memory and access the minimized memory to use it fastly on the chip register, leading to the improved performance. And this manual register allocation is flexible and controlled over the register usage, enabling the developers to fine tune their code for specific microcontroller requirements. And however, this approach requires more effort and expertise as the developers must carefully manage register dependency and ensure the optimal register usage throughout their code. So the last topic, that is optimizing register allocation, we have compiler optimizations, hardware awareness, and profiling and analysis. Coming to the compiler optimization, advanced compiler techniques can optimize register allocation by analyzing the code patterns and making strategy to minimize the memory accesses. Coming to the hardware awareness, considering the specific hardware capabilities and constraints of the target of microcontroller can lead to a more efficient register allocation. Coming to the profiling and analysis, comprehensive profiling and analysis of program behavior can identify hotspots and guide the register allocation decision and minimize the performance of the memory allocation overhead. So, what are the challenges and the best practice of register allocation? The challenges are register allocation on the microcontrollers can be complex with limited memory, diverse instruction set, and tight performance requirements posing significant hurdles. The best practices are carefully analyzing the code, utilizing the compiler optimization, and employing manual techniques like register pinning can lead to efficient register allocation and improved overall system performance. Coming to the microcontroller consideration, we'll get to know about accounting for a unique architecture and constraints of the target microcontroller is a crucial for developing efficient, effective register allocation strategies. So that was about this video. Thank you for watching. Please do like and share the video.